at x equaling 0, f of x has a relative minimum. Okay? That's the sign chart. We have an interval that we determine. We look at a test value. We determine the sign of the derivative, and then we draw our conclusion. Are we done? Well, let's see. Find open intervals in which the function is increasing or decreasing. Locate all relative extrema. So at this value, the function is has a relative minimum. Where is the function decreasing? Or the function is decreasing. What interval would you write here? Yep, negative infinity to 0, and then this one would be 0 to positive infinity. Now, I can't remember what type of problems you have. On homework, and so they may ask you to set up a sign chart. This is what they're talking about. This is our way of looking at it. Are there other ways of determining this? Oh, yeah. Oh, yeah. And there's some, we can do it with the second derivative, but we're in this section 4.3, and this is our discussion of first derivative test. Okay, so let's go on and actually see what that theorem states. First derivative test. Let C be a critical number of a function. Again, is C an input value or an output value? Input value, critical number of a function. F that is continuous on an open interval, differentiable on the interval, should be continuous on the closed interval, differentiable on the open, except possibly at the value C. It's differentiable except possibly at the value C. Remember, our critical numbers are those where the first derivative is 0 or undefined. And that's why it says it's differentiable on the interval except possibly at C. We don't know for sure. Then the function f of C can be classified as, and let's take a look at this, if the first derivative changes from negative to positive, then there's a relative minimum of the function. The first derivative goes from negative to positive. That means that the first derivative goes from negative to positive. Our function follows the direction of those, and so we would have a relative minimum. If the first derivative changes from positive to negative, then we have a relative maximum. Positive to negative, relative maximum. If the first derivative does not change, then it's neither a positive or a maximum. It's kind of a reiteration of what we just talked about, isn't it? Pretty much the same thing. Okay. Let's get an example of this. We've got our function, t squared sine t, in the interval from 0 to 2 pi, so just one rotation. First of all, differentiate f of t. Sketch the functions f of t and f prime of t, in other words, the function and its derivative on the same axis. Find critical numbers of the function in the open interval 0 to 2 pi. And find the intervals in which the derivative is positive and in which the derivative is negative, hence find any extrema. So let's take care of the first one. Once again, we have to use what rule to differentiate t squared sine t? Product rule, so we've got t squared times the derivative with respect to t of sine t plus sine t derivative with respect to x squared. Okay. Oops, you're absolutely right. How quickly we forget the variable. We've got to make sure we got those in. Thank you. Did I make the mistake anyplace else? Yes, we got it. Okay. So t squared times cosine t plus sine t times 2t. So I'm going to put that in parentheses. Remind me that it's not sine t 2t. 2t for t. Okay. Let's see here. What can we do with this? What do we need to be able to do? If we're going to, we differentiated it, that's fine. But down in part C, we want to find critical numbers. So the only thing I can think of is to possibly pull out a t, and then we have t cosine t, that's a cosine there, plus 2 sine t actually I factored out a t, didn't I? That'd be it. Okay. Let's jump to this one. Sketch the graphs of both the function and the derivative. Okay. And I'm going to suggest that we immediately change the attributes of one of them. So I'm going to change the attribute of this so that it is maybe a little more bold than the other one I'm going to draw. Oops. Let's try this again. Okay. Tab if you need the entry line back. And if you look up here just for a brief moment, notice that when I put x, cosine x, it doesn't recognize it as multiplication between x and cosine x. It thinks that xcos is the name of one variable. So if you keep your eye on the fact that if it's italicized, it means one thing. So make sure that you have that multiplication sign in there. And I'll go back and make sure that I've got this correct. Okay. Oops, didn't look like. What is it? Oh, yeah, right there. Yeah. Yep. Okay. There we go. Now, we have an interval, right? So this is going to help us a lot. Let's change the interval. It goes from 0 to 2 pi. So that will help us. I'll make mine pi divided by 2 up to 5 pi divided by 2, scaling by pi divided by 2. Yeah, I see that. Okay. And I don't need this much space, maybe. Let's go, although it looks like maybe. I'm going to say negative 10 to 10. I forget what I'm seeing down there, so we can always go back and change it. Okay, so I do need a little more space on the negative side, so we'll take care of that. Okay, so I'm going to then take that hint and make mine negative 30 to make it a nice even number, and probably move the maximum up to 5 since I don't need quite so much, and scale it by 5. Let's see if that works. Yeah, it looks a little better. Okay, so my derivative is the lighter one, and my function is now the darker one. Okay. Trying to remember, have we done this before? Those look almost the same, don't they? Look almost the same. They're just like it's a shift over just a little bit, at least what this part of it. But what I'm interested in, more importantly, is if I take a look at the derivative. Now, if the derivative is 0, what do you know about the function? If the derivative is 0, this is the derivative. If it's 0, what do you know about the function? Yes, James. Or minimum. Yeah, it's one of the critical numbers. Okay, so take a look straight above. I think we've done this before. Would you see that that appeared to be a maximum or minimum here? If I take a look at the 0 here, now I'm going to go to menu and I'm going to do my analyze graph and look at zeros. And I want a 0 of this function, so I'm going to draw a little window there. And over here, do the same thing. And draw from here to here. So it appears that somewhere at about 2.29 on the derivative, I have a derivative value of 0, and just about 5, I have another one. So if I'm looking then to the left of this point, my first derivative, take a look at the first derivative here. My first derivative is positive to the left of that point. How do I know my first derivative is positive to the left of this point? Is the first derivative increasing? The function's increasing, but how do I know that the derivative's value is positive? It's a very simple, basic question, but we often overlook it with this. Molly? It's above the input axis, isn't it? The derivative is above the input axis here, so therefore the derivative has a positive value. From here over to this one, the derivative is below the input axis. What's happening to the function? The derivative is negative, so the function from here to here is decreasing. The derivative is negative because the derivative falls below, okay? And the derivative is above here, and so at this point, from this point on, the function is increasing because the derivative is positive. Now, this the coordination between the graph and this derivative on the same coordinate plane is something where you really have to get into what is the derivative saying to us, what is the derivative information giving us, and how do we interpret the fact that the derivative is below this axis. I've got an activity. I'm trying to decide. I'd love to be able to have you do it. In fact, I may give it to you as extra credit to work on. How many of you worked with, let's call it the CBR? It's a motion detector device. Okay? Hannah, you have? Okay. You might have, Brandon? Okay. Was it in math or in science classes? Yeah, okay. It's a wonderful, okay. Okay, yeah, okay. It's a wonderful mathematical piece. And what I can do is we can set it up, and I'll have to check it out to make sure that I'm not forgetting a step.